Welcome to another deep dive. This time, we're going to try to turn your understanding of the universe inside out.
Wow.
We've got some research papers and articles about black holes.
Okay.
And yeah, this stuff's amazing.
Yeah.
It really challenges like everything we thought we knew
Right.
about these cosmic enigmas, right? We're talking mass, gravity,
Yeah.
even a fresh take on E equals mc squared.
It is. It's a fascinating shift in how we look at it.
Right.
I mean, we always imagine black holes as these
Yeah.
monstrous objects with unimaginable weight.
Yeah.
But what if that weight, as we understand it,
Yeah.
doesn't actually exist inside a black hole?
Okay, now you got me. How can something so massive
Yeah.
not actually weigh anything?
Think about it this way. Weight is just the force of gravity
Right.
acting upon an object's mass.
Mhm.
But inside a black hole, gravity becomes so extreme
Right.
that it warps space-time itself,
Okay.
making the concept of weight as we know it essentially meaningless.
So are you saying that inside a black hole, the usual laws of physics
Exactly.
just don't apply?
Yeah. It's like trying to use a ruler
Right.
to measure the curvature of a sphere.
Oh, okay.
It's just the tool just isn't designed for that kind of geometry.
That's both terrifying and amazing.
Right.
Yeah.
And that's where this idea of information density comes into play.
Okay.
Black holes are thought to be the most information-dense objects
Right.
in the universe,
Okay.
squeezing an incredible amount of matter and energy
Yeah.
into an infinitely small point called a singularity.
I'm trying to wrap my head around that level of density. It's like taking all the books in the Library of Congress
Right.
and somehow compressing them into a single atom.
That's a great analogy.
Yeah.
Yeah, and it's this incredible density
Yeah.
that warps space-time so dramatically,
Right.
creating the intense gravity we associate with black holes. It's not
Yeah.
just about mass. It's about how
Yeah.
much information is packed
Yeah.
into a given space.
Okay, that's a game changer. So if information density is the key to understanding black holes, how does this information actually influence gravity and space-time?
Well, the sources you provided delve into this idea of
Right.
coherence and decoherence.
Right.
Basically, information can exist in different states of organization.
Okay.
When it's highly organized or coherent,
Right.
it can influence the flow of information
Yeah.
and even bend space-time itself.
Right.
Think of a perfectly ordered library
Okay.
where you can instantly find the book you're looking for.
Right. The information is easily accessible and efficiently arranged. So
Right.
what happens when information becomes decoherent?
When information is disorganized or decoherent,
Right.
it becomes more resistant to motion.
Okay.
Imagine that same library
Okay.
with all the books scattered randomly on the floor.
Yeah.
Suddenly finding what you need becomes much more difficult.
Yeah.
This resistance to motion is what we perceive as mass.
Yeah. So you're saying that mass is basically just a manifestation of,
It's a radical idea for sure.
yeah, disorganized information.
Sure.
That's blowing my mind a little bit.
It gets even wilder when you apply this concept
Okay.
to Einstein's famous equation, EMCR,
Oh, I can't wait to hear this.
right?
Everyone knows EMCR,
Right.
but I have a feeling you're about to give it a whole new meaning.
The sources suggest that energy, E, in this equation,
Okay.
can be thought of as information coherence density,
Okay.
essentially how densely packed and organized
Okay.
the information is. Mass, as we've discussed,
Right.
becomes a measure of the concentration of information.
So instead of thinking about energy and mass as separate entities, we
Okay.
can view them as different expressions of information. That's a pretty
Right.
big shift in perspective.
And then there's CPOC, the speed of light squared.
Wait, how does the speed of light fit into all of this?
Right.
I thought that was just about how fast photons travel through space.
It turns out the speed of light might have deeper implications.
Okay.
The sources propose that CFD acts as a scaling factor,
Oh, yeah.
connecting the density and coherence of information, mass,
Ew.
to its potential energy.
Oh, yeah.
It's like a universal exchange rate for information,
Right.
dictating how much energy can be stored or released
Okay.
based on how that information is organized
Right.
and how quickly it can be transmitted.
So the speed of light isn't just about how fast light travels.
Exactly.
It's about the fundamental speed limit
Exactly.
of information transfer in the universe.
And that has mind-blowing implications for how
Yeah.
we understand energy, mass,
Right.
and even the evolution of the cosmos itself.
This is definitely a lot to process,
Yeah.
but incredibly fascinating. So we've talked about information,
Right.
density, and even how EMCOF can be reinterpreted
Yeah.
through this lens. But what about other fundamental concepts
Right.
like pressure, heat, and even the speed of light itself? Do they also tie back to this idea of information?
That's what we'll dive into next.
Ah.
It turns out that even these
Okay.
seemingly distinct phenomena might be emergent properties
Okay.
arising from the way information behaves within a system.
All right. You've officially piqued my curiosity.
Okay.
I'm ready to go even deeper down this rabbit hole.
Right.
Okay. So we're venturing even further into this mind-bending realm where information seems to be the foundation of reality. And I'm particularly curious about, everyday concepts like pressure and heat and how those fit into this picture.
Okay, sure. Well, let's start with pressure. The sources suggest that pressure at its core might be a measure of how information is being transferred within a system.
Okay.
The more densely packed and energetically active the information is, the greater the pressure it exerts on its surroundings.
So it's like information is trying to find space to move, to express itself, kind of like a crowded room where everyone's jostling for a bit of breathing room.
Exactly, yeah. Now consider heat. Okay. The research indicates that heat could be understood as the velocity of information exchange within a system. Higher temperatures mean information is being transmitted more rapidly, leading to increased kinetic energy at the particle level.
So as information gets more energetic and moves faster,
Right.
we perceive that as heat.
Exactly.
It's like a cosmic dance floor where the tempo is set
I like that.
by the speed of information exchange.
That's a great way to visualize it.
Yeah.
And this brings us back to the speed of light, which we touched upon earlier.
Yeah.
It's not just about how fast photons zip through space. It represents the ultimate speed limit for information transfer in the universe.
So if the speed of light is the cosmic speed limit for information,
Right.
does that mean there are constraints on how quickly energy can be transmitted
Absolutely.
or converted?
That's where that c squared and E equals mc squared becomes so crucial. It's the scaling factor that links the concentration and coherence of information mass to its potential energy and how rapidly that energy can be expressed or transferred.
So the speed of light is essentially a universal regulator for energy flow based on the organization and density of information.
Exactly.
It's like a cosmic traffic controller, ensuring that information doesn't exceed the speed limit and cause chaos in the universe.
Exactly. It's a fascinating way to think about how the fundamental constants of nature might be interconnected through this lens of information.
Now, you mentioned earlier that this new perspective on information and gravity raises some intriguing possibilities.
Yeah.
Specifically, the idea that we might be able to manipulate gravity
without
needing massive amounts of matter.
Yeah.
Can you elaborate on that a bit more?
Of course. One concept that emerges from this information-centric view is the idea of information-based gravity.
Okay.
This suggests that gravity might not solely arise from mass itself, but from the way that it is. Quantum information is structured and entangled across space-time.
So instead of needing a gigantic planet or star to generate gravity, we might be able to create localized gravitational effects by manipulating information patterns.
That's the theoretical idea. Of course, this is still highly speculative, but if we could control how information is arranged and entangled, it might open up possibilities for technologies we can barely imagine today.
Like what? What kind of mind-blowing applications?
Well, imagine being able to generate artificial gravity without needing massive structures.
Okay.
Think of spacecraft or even buildings with customizable gravitational environments.
That would revolutionize space travel and architecture.
Exactly.
No more bulky rotating space stations
Exactly.
or limitations on building heights.
Or consider the possibility of gravitational shielding if we understand how to. Manipulate information to influence gravity. We might be able to develop shields that protect us from its effects.
Now that's a game changer. We could explore extreme gravitational environments, venture closer to black holes, or even build structures that defy conventional physics.
The implications are truly profound.
Yeah.
And it doesn't stop there. The sources you provided also touch upon other frameworks that challenge our traditional understanding of gravity.
Okay, what else is there? I'm ready for more cosmic curveball.
Okay, well, there are modified gravity theories like MOND, which suggests that the relationship between mass and gravity might not be as straightforward as Newton's laws dictate. It proposes that under certain conditions, gravity might behave differently than we expect, potentially opening up new avenues for manipulating its effects.
So we might not need to rewrite the laws of physics.
Right.
Just refine our understanding of how they operate
Precisely.
in extreme environments.
Then there are concepts like the holographic principle, which posits that all the information about Takudi, a three-dimensional region of space, could be encoded on its two-dimensional boundary.
Right. Are you saying that gravity could be like a projection from a higher dimensional information landscape?
It's a mind-bending idea.
But like a cosmic hologram.
That's essentially what the holographic principle proposes.
Yeah.
It suggests that gravity might be more fundamentally related to information on a surface than to mass within a volume.
Okay, that's a concept I'll need to ponder for a while. But if the holographic principle holds true,
right,
does that mean black holes, with their extreme information density, could hold the key to unlocking some of the universe's deepest secrets?
That's one of the most tantalizing aspects of this whole field of study. Black holes might not just be cosmic vacuum cleaners. They could be cosmic information processors,
right,
playing a crucial role in the evolution of space-time and the distribution of information throughout the universe.
So instead of just devouring everything that comes near them, black holes could be actively shaping.
It's a possibility that's driving a lot of cutting-edge research.
Yeah.
And it leads us to one of the most perplexing mysteries surrounding black holes, the information paradox.
All right, I've heard whispers about this paradox.
Right.
But I've never fully grasped what it entails. Can you break it down for me?
Sure. Essentially, the information paradox arises from the clash between quantum mechanics and general relativity when it comes to black holes. Quantum mechanics dictates that information cannot be destroyed, while general relativity suggests that anything that falls into a black hole is lost forever.
So we have two fundamental theories of the universe seemingly contradicting each other when it comes to black holes. That sounds like a recipe for...
It definitely creates a puzzle.
Yeah, some serious cosmic confusion.
If information can't be destroyed, where does it go when it enters a black hole?
Right.
Does it get trapped within the singularity? Does it leak out through some unknown mechanism?
Right.
Or does it somehow get encoded on the event horizon, the boundary beyond which nothing can escape?
Those are some seriously mind-boggling questions. Right. And I have a feeling the answers could revolutionize our understanding of not just black holes, but the entire universe.
You're absolutely right. Unraveling the information paradox could have profound implications for our understanding of quantum gravity, the nature of information itself, and perhaps even the fate of the universe.
This is all so fascinating, but I have to admit I'm feeling a bit overwhelmed by the sheer scale of the concepts we're discussing.
Venturing into realms where the very fabric of reality seems to warp and bend. But that's also what makes it so exhilarating. We're pushing the boundaries of human knowledge and glimpsing possibilities that were once thought to be the realm of science fiction.
All right, you've convinced me. Let's continue this journey of cosmic discovery and see where this information-centric view of the universe takes us.
All right.
Wow, I feel like we've journeyed to the edge of reality and back with this deep dive. We started with this seemingly simple question. How can something so massive not have any weight?
Right.
And ended up exploring, the very nature of information and its role in shaping the universe. It's pretty amazing.
What I find particularly compelling is how this information-centric view challenges our assumptions about what constitutes reality. We tend to think of the universe as composed of matter and energy.
Right.
But what if those are just surface-level manifestations of something, far more fundamental information?
It's like we've been looking at the universe's source code instead of just the program it's running.
Exactly.
Yeah. So if information truly underpins reality, what are the implications for our understanding of black holes? They're no longer just cosmic vacuum cleaners. They become these incredible information processors, potentially influencing the fabric of space-time itself.
Right.
So instead of black holes representing an endpoint, a place where information goes to die, they could be active players in this cosmic dance of information exchange and transformation.
And that leads us back to the information paradox, which highlights the tension between our current understanding of quantum mechanics, and general relativity.
Yeah.
If information cannot be destroyed, as quantum mechanics suggests,
right,
then what happens to it when it falls into a black hole?
You mentioned a few possibilities earlier. Does it get trapped within the singularity? Does it leak out somehow? Or does it get encoded on the event horizon? Is there a leading theory among physicists?
There's no definitive answer yet,
Right.
but there are some fascinating theories emerging. One idea is that information might not be lost,
Okay.
but rather scrambled
Right.
and encoded in subtle correlations within the Hawking radiation emitted by the black hole.
Hold on. Hawking radiation, that's the theoretical radiation that black holes are thought to emit.
Right.
But isn't that supposed to be completely random?
Right.
And devoid of any information?
That was the initial assumption. However, recent developments in quantum gravity suggest that Hawking radiation might not be completely random after all. It might carry subtle imprints of the information that fell into the black hole, encoded in the entanglement patterns of the emitted particles.
So the information isn't destroyed, it's just transformed and re-radiated in a way that's incredibly difficult to decipher.
Exactly.
Like a cosmic message scrambled by an incredibly complex
That's a great analogy.
encryption algorithm.
You would mean that.
Yeah.
Black holes are not the ultimate information destroyers, but rather cosmic encoders, transforming information and redistributing it back into the universe.
This entire deep dive has been one mind-blowing revelation after another. But I have to ask, what are the practical implications of all this? Does this, information-centric view of the universe lead to any tangible technological advancements or applications?
It's still early days, but the potential is vast if we can understand how. Information shapes. Gravity in space-time. It could lead to breakthroughs in areas like artificial gravity generation, gravitational shielding, and even space-time manipulation.
So the science fiction concepts we often see in movies and books, warp drives, wormholes, controlled gravity, might not be as far-fetched as we once thought.
The possibilities are incredibly exciting.
Yeah.
But we must also acknowledge the immense challenges ahead. We're grappling with some of the most fundamental questions about the nature of reality. And the answers are likely to be complex and nuanced.
Yeah. I'm both humbled and inspired by the vastness of what we've explored today. We started with black holes.
We did.
But ended up delving into the very fabric of the universe and the mysteries of information itself. Well, I think it's safe to say that our understanding of black holes, gravity, and even reality itself has been irrevocably altered by this deep dive. I'm left with a profound sense of wonder and a burning curiosity to see what further insights this information-centric view will reveal in the years to come. Thank you for joining us on this incredible journey.
It's been my pleasure. And remember, the universe is a vast and mysterious place, and every new discovery is a testament to the power of human curiosity and our drive to explore the unknown. Keep questioning, keep seeking, and who knows what wonders you might uncover.